This is Applications Quadratic style. We're going to kind of jump right into a few things that can happen in the problems that you guys are going to get. First and foremost, you have initial velocity affects the path of an object. For example, you could drop an object here. Just dropping an object that has no initial velocity. Here you're actually throwing an object up, and here you're throwing an object with a little more arc to it. So you have to kind of pay attention to what the word problem is telling you that the object is doing. So also, the object does not always start on the ground. So you could start on a table, you could start on a building, depending on what it is. The object, like I said from the previous one, if you just rolled this off the hill, it would not start on the ground here. Here, this doesn't start on the ground, it starts in your hand, but the object will eventually hit the ground. If you notice here, it eventually hits the ground, so you have to kind of pay attention to what that does. And you have also downward velocity versus upward velocity. If you notice, a football player, if they're spiking the ball, that's a downward velocity. They start here, and then they just throw the ball down. Whereas a basketball player, what they'll do is they'll have an upward velocity, and then it will start to come down. So you have to pay attention as to what's being done. And the cool thing is, in physics, this formula actually tells you and gives you a model of what a certain object will do in the throwing path, or what the object is doing over the course of time. So what we have is we have h, and h is your final height after a certain amount of seconds happens. That equals -16, which is a constant in this. We have t squared. T is your time in motion, so time is the amount of seconds. Plus or minus. This can be either plus, depending if you're throwing upward and then it comes back down, or if you're starting, it would be a minus if you're throwing an object and just dropping an object downwards. So you got to pay attention as to what is going on in the problem. So we have the v, which is the initial velocity, and I'll always tell you what that is. But if the object is just dropped here, there is no initial velocity. It starts off at v is equal to 0. So sometimes you have to pay attention and see what the object is doing. Your s is your initial or starting height. If you're a 5-foot person and you're holding an object at 5 feet, that would be your starting height of where that object starts. If you're standing on top of a cliff that's 50 feet high or something like that, you have to compensate for that. So, but again, all these are going to be given to you. You basically have to just plug them into the formula as you see. Okay, so here we go. So I've got the formula over here. It's kind of small to kind of see, but you have your h, your s, your t, and your v. So we have you retrieve a football from a tree 25 feet above the ground. You throw it downward with an initial speed of 20 feet per second using a vertical motion model, which is this is your vertical motion model, to find how long it will take for the football to reach the ground. So here's what I'm going to do. We're going to first plug this in and kind of see where we're at in terms of what the object is. So we have, you retrieve a football from a tree 25 feet above the ground. This is important, 25 feet above the ground. What that is it's your S. It's your initial or starting height. So that's your S. I'm going to label these as we go. You throw it downward. So downward is important. So we have downward means that your plus or minus is actually going to be a minus, and a downward initial velocity at 20 feet per second. So that's actually going to be your V here. And use a vertical motion model to find what's what. So all I'm going to do is I'm going to say h equals, and it will always be h equals -16 t squared. That's going to always be constant in every single one of these. But what's not going to be constant is this part and this part. So you have to kind of see what's going on. So I'm going to look at my v. Since we're hitting downward, that means you're going to have a minus. Your initial speed of 20 feet per second means it's going to be -20, and you have times that by t, because that's part of the formula. That's right here. That's your t. Okay? Then you have your s. Your s is your initial height, which is right here. So that's plus 25. So this is the function that you're going to try to find and use to answer the question. So what is the question? So it says use the vertical motion model to find out how long it will take for the football to reach the ground. So you have to ask yourself, if the football reaches the ground, what is the height? Well, that would be a 0. So negative 16t squared minus 20t plus 25. Now, what you could do is you could use this and find out using the quadratic formula, plug it in and figure out what your 2 times are in terms of t. But if that's the case, that would take you a long time. You have a wonderful piece of technology, and we're going to use that wonderful piece of technology. So here is your wonderful piece of technology, your graphing calculator. So here's your graphing calculator. Now I'm going to get this, so you should have what that initial time was, or I'm sorry, your formula. So I'm going to plug this in. We had negative 16 t squared. So I'm going to use x, quantity squared. Then I have plus, or I'm sorry, the minus 20, because that's your initial velocity thrown downward, times your x plus 25. Double check to make sure that you have this in the calculator correctly, because if you're missing an x here, it's going to throw everything off. If you miss the 25, it's going to throw everything off. If you have a negative here instead of the minus sign, remember that's different in this calculator, it's going to throw everything off as well. But once you have this, you can press graph. So let's look and see. So I was lucky, and I see that I have this function here. If you are not lucky, you can go zoom and then go to fit, which is, I believe, number 10 for you guys. Zoom fit, press enter, and that gives you that. What I'm going to do is I'm going to clean this up a little bit, and I'm going to go to the window, and instead of going 31, which was the height, I'm going to keep that as 31, but I'm also going to go down, not negative 1775, I'm going to go down only 10, just to kind of see where it's at. And that gives me this, which is kind of nice. So what are we trying to find? If we're trying to find out how long it will take for the football to reach the ground, remember that's the initial question here. So the football, trying to hit the football to reach the ground, that means your height is 0, so we're going to try to find the 0. So how you do this, second trace, go to 0, enter. Left bound, right bound, remember you go, use the tracer, left and right arrows, as close to the 0 as possible. To the left of the 0, your y values are positive, so I'm going to go 2 clicks to the left just to make sure I'm to the left of the 0. Go as close to the 0 as possible, 2 clicks to the right. Notice it's off. If you want to see that it's on, that's fine. It doesn't matter as long as it's to the right or in the negatives. You want to make sure your y is negative in this case. Enter. And it tells your calculator to look between these two, just like we did before in applications in the previous section. Press enter a third time. So what this says is after 0.77 seconds, this object will reach the ground. So that is your answer, 0.77 seconds. Okay, so your next one, you have a baton twirler tosses a baton into the air. The baton leaves the twirler's hand 6 feet above the ground. That's important. And has an initial velocity of 45 feet per second. The twirler catches the baton when it falls back to a height of 5 feet. For how long is the baton in the air? Here's your initial velocity, your model of what this is going to look like, and we're going to just kind of go through this step by step like we did with the previous one. So first and foremost, we have 6 feet above the ground. That here is your initial velocity, so, or 6 feet above the ground would be your initial height. So that means that's your S. So you can actually say S, or say S is equal to 6. We have the initial velocity, which in this case, initial velocity of 45 feet per second. So now you have to look and see if the twirler's hand, and you have to use a little bit of common sense. Well, what's going to happen is you're going to throw it up with an initial part, and then it's going to come down. So that means that your initial velocity is going to be positive. So this here is going to be your V, and it's going to be positive, so it's going to be positive 45. And then it says the twirler catches the baton when it falls back to the height of 5 feet. This is the second part of the equation, but we're going to first do this part here. So what I have is I have a height of the baton is negative 16 t squared. Remember, that's always going to be the same. Then we initiate our velocity, which is plus 45, and don't forget the t. And then you have your initial height, which is going to be plus 6. So that uses those first two, this part here and this part here. But then you have this third part, this 5-foot part. It says the twirler catches the baton when it falls back to the height of 5 feet. For how long is the baton in the air? Well, here's the deal. All time starts at 0. So time starts at 0. So that's your starting time. But the baton, how long is it going to be? 5 feet. So you're going to say that your other height is going to be 5 feet. So you basically have this here and this here, two different equations. So we did this in the previous section as well. So you can think of this as y equals 5, and this one up here is y equals negative 16t squared plus 45t plus 6. Okay, so we have these two equations. We have this one here we have to plug into our calculator. We have this one here we have to plug into our calculator. And we have to find out where they intersect. So let's actually model this in the calculator. Okay, so I'm going to clear my buttons just to kind of start off from scratch, and we got y equals. I'm going to clear this as well. And my window is probably going to change, but we're going to keep it as is, just plug in our values. So we have our first equation, which was negative 16. Remember, the t becomes an x, quantity squared, plus 45t, plus the 6. Double check, make sure you have everything in place. The negative is a minus sign, or it's not a minus sign, it's a negative, so it's this button here, not this button, because you'll get an error. Your x squared, 45x, and the plus 6, so that one's good. So now I'm going to go down and type in the second one, which is going to be y equals 5. So when I graph this, I get this, which is kind of nice, using the same window, so I'll be honest with you, I'm not going to mess with it. What it asks for in the question is for how long is the baton in the air? Well, here's the deal. If I look at this calculator, at time 0, remember it starts 6 feet above the ground, and the person throws it, comes up, and then it comes back down, and this is your 5 feet. So we know it's from 0 to some number, and it's at this point where the object hits that it actually hits the 5-foot arrow. So we have to find the intersection of this. So what you do, I'm going to clear my buttons here, second trace, and I'm going to go to intersect. Enter. And then you get your tracer thing. So what you want to do is you want to go over as close to the intersection as you possibly can. So there's as close to the intersection. That's pretty darn close. And you're going to press enter 3 times. 1, 2, 3. And the calculator gives you at 2.83 seconds, or 2.835 seconds, your height is going to be 5 feet. So your x value, 2.835 seconds, is your answer. That's how long the baton is in the air. It's from 0 to 2.835 seconds, done. All right. This next one, we have Mr. Henderson is going cliff diving. He climbs to the top of a 50-foot cliff and steps off. How long will it take for him to hit the water? So now let's go through and identify what we need, what our parts are to the negative 16t squared plus or minus the v, t plus the s. So I look and I see, okay, so he climbs to the top of a 50-foot step off. So all he's doing, it's taking him to hit the water, so he's literally just walking off. So he doesn't have an initial velocity. So this part of the equation, we can actually just forget about. So the negative 16, so you got the h equals negative 16 t squared. We know that's part of it. This part here is the only part that we actually need, which is your s. So s is equal to 50, because that's your initial height that you're starting at. And it doesn't tell you that you have an initial velocity, so this is literally all you can take away from this equation. So now that we have the equation, what we're going to have to do is we're going to have to graph in our calculator, and I'm going to see if this window actually works. So I'm going to go to y equals, I'm going to clear out my two equations from the previous question, and we got one, we got two, and I'm going to plug this one in. So we got negative 16 t, which is my x value, quantity squared, plus your 50. That's the only parts of the equation that we need. So I'm going to graph this, I'm going to see how it looks. So that's kind of nice. It actually works for all three of these. The window actually kind of works. Okay, so with that said, now we have to find where this is going to hit the ground, because that's what's being asked. So it says, how long will it take for him to hit the water? So that's at your height equaling 0. So my height equaling 0. So if Mr. Henderson's way up here, he falls off, forward, and bam, this is where he hits the water. So I have to figure out where that 0 occurs. So I'm going to go clear these first so you can see what buttons I'm pressing. Second, trace 0. So you have your zeros, go over until you can see the tracer, and you want to make sure you pay attention to what the x value is looking at, right? So you're left bound. That means you need to go to the left of the 0. To the left of the 0, your y value is going to be positive. So I'm going to look at my y value. And until it's positive here. It was positive here, so it doesn't matter which one. So I'm going to press enter. Go to the right until it says negative, because that means I'm to the right of the 0. I press enter, enter a third time, and that gives me my 0 occurring at 1.768 seconds. So how long will it take for him to hit the water? That's at 1.78 or 1.768 seconds. And that is your answer. Okay, and your next one, here we go. So we have Bobby is at the plate. So this is a baseball thing. So there is 2 outs and the bases are loaded. So that's the scenario. That is really mostly just kind of all excess stuff. So Bobby swings and connects with the baseball 3 feet above the ground. Bam! There is where our information that we need lies. So we know that this part here is important, 3 feet above the ground. The baseball has an initial velocity. That's what you're looking for, initial velocity. So your initial velocity of 96 feet per second. So let's label what we have. 3 feet above the ground, that's your S. So S is equal to 3 feet. That's your initial height. Then you have your velocity. Initial velocity of 96 feet per second. It does not say a downward motion, so we say 96 feet is your initial velocity. It's positive. So we're going to put this into the formula form. So we have negative 16 t squared. It's positive v, which in this case is 96 feet, times t, plus your s, which is 3. And that's your h. So this is your equation that you're going to be using throughout this entire part. Okay? So now we have our calculator. So let's grab the calculator. And I have my y equals. I'm going to clear this out and start from scratch. So now I've got negative 16 x squared plus 96x plus 3. Double check to make sure my characters are right, and I'm going to go ahead and graph it. Now this one's way off the graph. So the first question that's being asked in this is, what is the maximum height of the baseball? So we need to figure out what that maximum is, and this isn't actually showing up. So I need to go to my window, and I know for a fact I'm going a little bit higher than 31.24. So I'm going to try 100, see how that works. So I'm getting closer, I'm able to see it, so now I'm going to try, you know what, let's try 200. And again, this is just trial and error. You kind of increase the y values as you see fit until you can actually see the object. So there is the object. So now the question that's being asked is, what is the maximum height of the baseball? So I'm going to look and see. there's my maximum. So what I do is I go second trace maximum. Enter. See, my tracer is here. I go as close to the maximum as I can. I go 2 clicks to the left, press enter, 2 clicks to the right. Make sure you're decreasing when you do 2 clicks to the right, and enter a third time. Okay, so after 3 seconds, that is the height of the baseball is 147. That's your maximum height. So the first question is asking, what is the maximum height of the baseball? You would write down 147 feet. How long does it take the baseball to hit the ground? So here we go. How long does it take the baseball to hit the ground? We have to look and see. So if this is your baseball player, he hits the ball, goes up and back and back and back, and then starts to lose its height, and then bam, hits the ground. That's where we want to find. So where does it hit the ground? We go second trace, 0 is where it hits the ground. Go as close to that 0 as you can. And you want to make sure to the left of the 0 is going to be a positive y value. So watch my y values. There's where my positive y value is. I'm to the left of it. I press enter. Go as close to the 0 again. Go to the right, which means I'm going to go into the negatives. You need to have a sign change. It needs to go from positive to negative, or if you're going from here, it would be negative to positive. But this is the one that we're concerned with. Press enter a third time, and you get after 6 seconds, your height is going to be 0. So that's where the ball hits the ground. So after 6 seconds, how long does it take the baseball to hit the ground? You would say after 6 seconds. Now here's the tricky one, and we used this in the previous question. So how long does it take for the baseball to hit a height of 75 feet? So I have to introduce another y equals to this. So what I'm going to do is I'm going to say, okay, this is the ball. It travels at a certain height, and then it hits the ground. So where do I know where 75 feet is? I'm going to graph 75 feet in this calculator. So graph 75 feet. There's my 75 feet. It's a horizontal line. And now here's the question. What is it asking? How long does it take for the baseball to hit a height of 75 feet? Well, here's the thing. It hits a height of 75 feet 2 different places. But we want the initial one because it doesn't say or ask for both. You just want to say how long does it take the baseball to hit the height of 75 feet. So what you do is you go second trace and you're going to find the intersection. So intersection, take your tracer, go as close to the intersection as possible, enter, 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 and there's your intersection. After 0.879 seconds, this will hit a height of 75 feet. So what's the answer? So your answer would be, how long does it take for the baseball to hit a height of 75 feet? That would be after 0.8787 seconds, depending on how you round it. It's up to you. 4 decimal places is good, 3 decimal places is fine, but that is your answer to your question. All right. When I initially saw this, this was one that I thought was a very, very tricky question. So I'm going to try and go through this as quickly, as intricately as I can, in as much detail as I can. But no matter which way you slice this, this is a very tricky question. But you might want to star this or highlight this because you're going to see this on your quiz or on your test. So something you're going to want to practice. So we have a cafe, has an outdoor rectangular patio. The owner wants to add 329 square feet to the area of the patio by expanding the existing patio that measures 15 feet by 25 feet. If the cafe would like to increase the width and the length of the patio by the same amount, that's key, by what distance should the patio be extended in both directions? What would be the new dimensions? So here's the deal. This is why this is tricky. First of all, the velocity stuff we are done with. This is not a velocity problem, so we're not trying to find our V or our S or anything like that. What we do have to have is we have to have a little bit of a visual. So we have an initial patio that measures 15 feet by 25 feet. I'm a very visual person, so I'm going to draw some pictures here. What we want to do is expanding the existing patio that measures this. So we know that the owner wants to add 329 square feet to this. So we're going to look at this in a second. So we know that this is important. Okay, we want to expand the patio, so that means we're going to add a certain amount, and it says expand the patio by the same amount. So that means I'm going to add the same amount here as I do to here, and I'm going to add the same amount here as I do to here. So here is the deal. This is why this is tricky, because you first have to know if this is a rectangular patio, what is the area of a rectangle? And everybody remembers it as length times width. When you get to geometry, it's probably going to be a little easier to say base times height, but we'll go length times width in this case. So our length and our width. We have our initial length is 15 feet. We have our initial width is 25 feet. But what's happening here? Well, here's the deal. You're trying to expand it by the same amount. So what happens to that original width, or I should say length? Well, you have this x value here that's being added, and you have this x value here that's being added. So that means you have two x values that are being added. Same deal for the width. If you're adding this part to this part to this part, you have the 25 feet. You have this x value, and you have this x value, so you're adding two more x values. So that's your area. But here's the deal. The owner wants to add 329 square feet to this. So the deal is, we know that we have this amount is area. And this is where this is super tricky. And I apologize, but it just is what it is. So we have our length times width. We have to take this part out because we do not want to compensate for this part. We just want to have this part here, this outer part area, as your 329. So your outer area, you have to subtract off the 15 by 25. So you're subtracting off the 15 by 25 rectangle. Well, what is 15 by 25? That's 375. So if I take out this rectangle here, if I take this out, and I'm just trying to find this area that's in here, that should be 329. So 329. Okay? So if that's the case, now I have to get this in quadratic form to where I can actually solve it. But I'm not going to make you FOIL this out, collect like terms and all that stuff. I'm going to make you have your calculator do most of the works. The only thing that I really need to do is I need to simplify it and get everything on one side. So I'm going to subtract 329 from both sides. What I'm going to do is I'm going to get a 15 plus 2x by 25 plus 2x. And I'm going to subtract off, if you add those two parts here, these guys go away, and you're left with negative 704. So you have minus 704. And of course, I can't write it because I'm running out of room. So let's go away here, minus 704. There we go. Okay, so this is going to be your area that you're trying to find. So this, when we did this, now this area part here is equal to 0. So we have to find out where this equation is 0. So now we get to use our calculator. Like I said, you probably want to go through this a couple more times because this is what engineers have to do and how they have to think. So I'm going to exit out of this and I'm going to go to our calculator. So here's our calculator, and I'm going to clear out of this, clear out of this, clear out of this, and I'm going to plug in our long and complicated equation, which was 15 plus 2x, and then I have my 25 plus 2x, in parentheses, and I subtract off the 704. Okay, once you do that, you're going to graph this. Now, this is going to be something that we're going to see. Yeah, see, here you go. What we want to do is we want to find out where this actually hits 0. So we're going to go zoom, fit, and see if we have a nice looking quadratic. Okay, so this quadratic is upside down like this. So the only place where it hits 0 is right here, and that's what we want to find. So we're going to try and find our 0 here. So we go second trace, down to 0, enter. We're going to go over here as close to the 0 as possible, and it says left bound. Now remember, left bound, we want our y value, since it's increasing here, we want our y value to the left here, which means our y value is going to be negative, and I look and I see I already have a negative y value. That's cool. Press enter. Now I want the right bound, which means I want just to the right, so my y value should be positive. Press enter, enter a third time, and it gives me a 3.5. You get a y value of 0. Now, that's going to be important, so let's go back to here. So we have our equation. So remembering this part here, we have our equation of our length of 15 plus 2x and our width of 25 plus 2x. And then we had this minus 704 part. But here's the thing. This part here is the important thing in terms of your rectangle. What it's asking for, it says, by what distance should the patio extend in both directions? So what we had here, if you remember this equation, how we derived it, we had our 15 by 25, and then we had our x here and our x here. What we have to do is we have to extend off 3.5 feet in both directions. We have to extend off here 3.5 feet and here 3.5 feet as well. So by what distance should the patio be extended in both directions? The answer to that is 3.5 feet. Now, the next one is going to be, what would be the new dimensions? Well, that's where you have to plug in into your L's. So we have 15 plus 2 times 3.5. That gives you 7 here. 7 plus 15 is 22. So it's 22 feet is your length. And to find your width, you would do 25 plus 2 times 3.5. And we figure that out is this part here is 7. 7 plus 25, that means my width is going to be 32 feet. So what would the new dimensions be? It would be a 22 feet or foot by 32 foot. New dimension set. So that's answer 2. This is answer 1. Now notice, in terms of time, this took a lot of time. So that took about 8, 9 minutes, almost 10 minutes to explain. So this is one of the reasons why you need to go back and probably practice this. Okay, so new one. We have a farmer is building a rectangular pen along the side of a barn for animals. So here is my picture here. So I got my barn here. It says the farmer has 121 feet of fence to enclose the area of 1,512 feet and wants each side of the pen to be at least 20 feet long. Find the dimensions of the pen. This one is another one that is super tricky. Sorry. So here's the deal that I notice. You're not going to put, the barn will serve as one side of the pen. So you're not going to put any fencing area on this side. What you're going to do is you're going to put fencing area here, here, and here. All of this added together gives you 120 feet. That's what you want here. Now here's the deal. We don't know what these dimensions are. So you can pick any one of these. For example, since we know that it is a rectangle, it's a rectangle. All of these are going to be rectangles to make it easier on you guys. So if we know that this is a rectangle, what I can do is I can pick one of the dimensions. For example, I'm going to pick the width here. And I'm going to say that this width is x, which means that this width is x. If we know the entire perimeter here is 120 feet, that means we can take 120 feet and subtract off these two x's to give us this length right here. Now, once we have that, now we have 1512 feet. It has to enclose this area of 1512 feet squared. So how do you find the area of a rectangle? Well, it's length times width again. So length in this case and width in this case. And we don't really care which one's which. So I can say my length is x. That means my width has to be the other one, which is 120, minus your two x's because of your two sides. One side here that is, and one side here. Okay. So now we have the x times the 120 minus 2x. What does that equal? Well, it has to enclose the 1512, so you set that equal to 1512 feet. In order to get this into a place where you can plug it into your calculator, you subtract 1512 from both sides. So we get x times 120 minus your 2x minus 1512. And that's going to equal 0. So now this one you're going to have to plug in to your calculator. So we're going to plug this into your calculator. So I'm going to delete this stuff here and do a new problem set. So we have our x times our 120 minus our two x's that we subtracted off from it. And then I subtract off the 1512. So that's the equation that we came up with in the previous part of this. Now, what did I do wrong? I pressed, but it didn't actually go, so I'm double checking to make sure. I insert a negative sign here, double check to make sure that's what I want, and there we go, we're going to graph it. So now I have to do my zoom fit to get this actually on the graph, so I'm going to go up to zoom fit or down to zoom fit, it does not matter. So I want to go a little bit further to the right to make sure I know this actually is going to be read in the calculator. So I'm going over 30, and I'm also going to go up a little bit as well. So I'm going to go up into the positives. Let's go up into, I don't know, 100. And we know it's not going to be in the minimums of negative 2,000, so let's go to negative 10, just because. Graph it, and there we go. So I got my part here, and that's really the 0 that I want. So I'm trying to find that 0. So I'm going to go second trace, 0. Enter. Now I have to find out where that tracer is. So I look and see, I see, okay, I have x equals 10, which means I probably need to go to the right until I see my tracer. See my y value here is increasing. You want to get the y value to increase to where you can finally see your tracer. So now you're above this. So now I'm going to find my 0. I'm going to go 2 clicks to the left. You want to make sure you're in the negatives because it's to the left of the 0. Enter. To the right, enter, enter a third time, and we know that it occurs at 18. So 18 is where the x value occurs, but what is being asked? So we have our part here. So we know x values, x are max. Or I'm sorry, we're trying to find our dimensions. So we had our x, which is our length. We are our width, which is 120 minus the 2x. That equaled 1512, but we subtracted the 1512. So now what's being asked is finding the dimensions of the pen. So we know that x is equal to 18. That's going to be our length, and it's 18 feet. We know the width has to be 120 minus the 2 times the 18. Okay, so that gives me 36, and I get 120 minus the 36. That gives me 84 feet. Now, if I did this, I would stop and I would say, yay, I'm done. Here's the problem. Right here. The pen side has to be at least 20 feet. So all that work I just did, this is wrong. This is wrong. There must be another x here. So let's look and see where that other x is. Okay. So what I'm going to do is I'm going to increase my my x value. So a good rule of thumb here is you want to find out and maybe see where they both hit. So we found out that this was 18, and that was below the 20 feet that we wanted. So now we're going to have to find our next one. So second trace down to 0. And I'm going to go over, watching the y value, look at the y value and what it's doing. Now it's coming back down. And I'm going to get it as close to that 0 as possible. So I need to the left, which is in the positives. It's already in the positive, but just visually to the left. I press enter. Now you want it to the negatives. Enter a third time, and then we get 42. So now let's see if 42 actually works. That's above 20 feet at least, but let's see if it actually works for both of them. So remember our dimensions. We had our length was x. We had our width is 120 minus your 2x. Okay, that should equal or minus the 1512, but we're not really concerned with that. What we are concerned with is the length. So let's see if the length equals 42 feet. That is perfect because that's above the 20 feet. So that one so far is good. But the width, we have to check. 120 minus 2 times 42. That gives me 120 minus 84. And that's going to give me 36 feet. So here's the thing. Both of these, the length is 42 feet. The width is 36 feet. Both of these are above 18, so we know that's true. And I'm going to do a double check here because we know that 1512 is our square footage that we're trying to enclose, so I'm going to figure out and see if that works. So I'm going to do 42 times 36 and see if that equals 1512, and absolutely it does. So that means that that is your dimensions. Now, look at the timestamp here to explain that. That was almost 10 minutes. These are tough problems, so you're going to probably want to revisit these a few times. So good luck. Let me know if you have any questions.